Hey everybody, welcome back to Rockpile Tutors. Today we're going to do another homework helper, this time from Algebra 2. We are going to be looking at operations with functions and composite functions. So we got our little function guy down here, and you'll be seeing what we're doing soon. So, what is a function? So a function, zoom in on this little guy here, this is what we're going to have as f of x. So a function is basically a guy with a very boring job, and f of x, all he does the same day is whatever input he gets, he does something to it. So in this case, we're going to say 2x squared minus 4 is his job. And all he does is he takes an input, which we're going to call x, and he creates an output that we're going to call y. And he knows that every x can only create one y. If he has an option of y1 and y2, then he is not a function. And I think you know that from functions. So today we're going to be dealing with normal, properly behaving functions that have one x and one y. All right. He comes to work and we're going to tell him, hey, give me the f of 6. Right, so he's going to take 6, he's going to turn the crank, and he's going to get 2 times 36, 72 minus 4, and he's going to output 68. Every time you give him a 6, he will output a 68. And that is what the basics of a function. So what we're going to be doing now is we're going to be combining functions. And we're going to be... Okay, so now we're going to have two functions. Okay, and they are going to be called f of x and g of x. Okay, and these guys are each going to do different jobs. So he's going to be 3x plus 2, and he is going to be 4x squared plus x plus 1. All right, they're both going to have their inputs and their outputs. And we're going to start doing some composite things, some functions, some operations. So we can do f of x plus g of x, right? And that, right, is going to take these outputs, because this is f of x, and we're going to apply that operation here. So to make f of x plus g of x, let's pick an argument here. Let's do f of 2 plus g of 2. So I put 2 in, I get 8 out. I put 2 in here, and I get 16 plus 2, 18 plus 1 is 19. And then I combine them, and so f of 2 plus g of 2 is 27. You'll also see this written f plus g of 2, and it means the same thing. Okay, so that is how you add functions. Now we can do this with any of the operations, and so now we're going to take a look at what happens when we subtract things. All right, so if I do f of 2 minus g of 2, or f minus g of 2, instead of adding, I'm going to subtract. So the way it's written, it's going to be 8 minus 19, which is negative 11. Right? We do the same thing with multiplication. If I multiply here, all right, f times g, notice that's a filled in circle, meaning times, so we're of 2 is whatever 8 times 19 is. 8, 19, I should have picked easier numbers, huh? 152. And similar for division. So I'm not going to go over division, but you get the idea. All right, next let's do a few problems. So if I take a look at number 1 here, I've got g of n. We'll put g of n, and we're going to write what he does underneath, n squared plus 4 plus 2n, and we have minus 3n plus 2. And we want to find g times h of 1. Right? So let's build our machine here. We've got our input is going to be 1. We've got our input is going to be 1. And our output here is going to be 1 plus 4 is 5 plus 2 is 7. So g of 1 is 7. H, we're going to do minus 3 plus 2 is negative 1. So g of h of 1 is 7 times negative 1, or negative 7. Make sense? Let's try. Okay. The next problem we're going to do is number 2. So I have f of x, which is 4x minus 3, and g of x, which is x cubed plus 2x. Okay, and I want to find f minus g of 4. All right, you know what that is. We're putting 4 as our inputs. And this output is going to be 16 minus 3, or 13. And this output is going to be 4 cubed, which is 4, 16, 64, plus 8 is 72. Okay, and f minus g of 4 is negative 59. Good. Okay, the next one we're going to be doing is an addition problem. So we're going to set it up for number 3 here, where we've got h of x, which is positive 3x plus 3, and we've got g of x, which is minus 4x plus 1. All right, set up our inputs and our outputs. And what is the problem asking for? It's asking for h plus g of 10. All right, what do? We set up our inputs and get our outputs. So 10 into h of x, 3x plus 3, 30 plus 3 is 33. Plug 10 into g of x, and I'm going to get negative 39. When I add them together, I get negative 6. And that's how we do it. All right, we've got it. All right, the last one we're going to do is number 4, which is a division problem. Let's set up our functions. G of a is 3a plus 2, and f of a is 2a minus 4. Here it matters which is on top and which is on bottom because we need g to be divided by f. So set up my boxes, and what do we want to do? G over f of 3. So I'm going to put 3 in. 3a is 9 plus 2 is 11. I'm going to put 3 in over there, and I'm going to get 6 minus 4 is 2, making g of f, or g divided by f, 11 divided by 2. And I suppose we should put this in proper form, which is 5.5. All right, that is pretty much operations of functions in a nutshell. Hopefully this guy with a crank metaphor is helping for you guys. And next we're going to get to the fun stuff. Now we're going to get into composition of functions, where we're doing functions of functions. So I have I've got these problems here, and I've got f of x is 3x minus 7, g of x is the square root of 2x plus 10, and h of x is 4x squared minus 3x. So we're going to start doing these problems, and we'll see what happens when we have to do functions of functions. So first on the stage is going to be f of x. So if I put f of x is in play, and they want f of -2. So I'm going to plug -2 in, and my output is going to be -6 minus 7, or minus 13. All right, they also want to know g of -5. I'm going to take g of x, plug that in, plug -5 in here, I get -10 plus 10, and that's my output of 0. And now we're going to do h of 2. 2 times 4x squared is, or 2 as x, 4x squared is 4 times 4, or 16, minus 6. That output is 10. All right, and now we're going to plug in h of -2. -2, x squared is 4. 16 minus a -6 is now 16 minus a -6 is 16 plus 6, or 22. All right. Now what happens if we bring in algebra? Really not much changes. All we're going to do is we're not going to have clear number answers. So if I look at the next one, f of a plus 1, what does that mean? That means I'm just going to plug in a plus 1 in here, and whatever I put in here, that's what goes in the x. So I'm going to have 3 times a plus 1 minus 7, which is going to be 3a plus 3 minus 7, or 3a minus 4. Right? And that's the answer here. All right, the next one we're going to do f of a plus h. I wish they hadn't used h here since it is one of our functions, but this is just the variable h is the way I'm going to solve it. So if f of a plus h means my input is a plus h, and my output is going to be 3 times a plus h minus 7. 3a plus 3h minus 7. Now this next one brings the h outside of the parentheses, so the only thing going into f of x is a. And now I'm going to get out 3a minus 7, and now I'm going to add the h. So that's going to be 3a plus h minus, I keep wanting to add that, minus 7. The next one we are going to do g of x minus 5. So x minus 5 is my input, and I'm going to have the output of the square root of 2 times x minus 5 plus 10. That's going to be 2x minus 10, so that's going to be the square root of 2x minus 10 plus 10, or just the square root of 2x. So we're going to do h of a plus b. That's going to be 4 times a plus b squared minus 3 times a plus b. You would write it right here. And now we get to the interesting one. We are now going to do f of g of 3. So what does that mean? That means I want to do f of a number, right? I want to do f of something. What I'm taking it of, I don't know until I've done g. And what that is going to do is it takes g, and we need the output of g, then becomes the input to f. So we go from the inside out. We can't do f of x until we know what g of x is, and so we do that first. So what this means is we take f of g of 3, put 3 in there, square root of 2 times 3, which is 6 plus 10, square root of 16, is going to be really plus or minus 4. I don't know if that's what they wanted here, but we'll do that. And so I have to now do this twice. So I'm going to put 4 in, and I'm going to get 3x, 12 minus 7 is 5. And then I'm going to put minus 4 in, I get minus 12 minus 7, negative 19. So f of g of 3 is 5 or negative 19. Okay, so that's how you do composites. You start from the inside. Once you've resolved that, that becomes your input into the next one. All right, hopefully you've now gotten the idea of composite functions. So let's do the next one. G of f of 3. So my inside one, the one I need first, is f of x. Right, and so I'm going to plug f of x. I'm going to take the output of that as the input to g. So we're going to line these guys up like this, and then we go to town. So if I put 3 into f of x, I'm going to get 9 minus 7 is 2. Then that goes into g of x, and I get 2 times 2, or 4 plus 10. I have the square root of 14. And that's all composite functions are. Okay, so the next one requires a little bit of words. When they show this h open circle g of negative 2, that's the same as h of g of x. And which do we do first? We do the g first. And so from the inside, we're going to bring something else with us. And then that output, g output, goes into h. All right, let's do that. And we've got negative 2 as our input. We don't want that. Negative 2 is our input. So we have negative 4 plus 10. This is the square root of 6. And with the square root of 6 as my input, I have 24 minus 3 times the square root of 6. And that's how we do h of g of negative 2. Next, we're going to flip that around, and we're going to do g of h of negative 2. Look at that. So now I need to do h of 2 first. I'm sorry, h of negative 2 first. So I'm going to plug that in here. Now I'm going to get 4 times 4, which is 16, plus 6 is 22. Now I'm going to put 22 in here, and I get 44 plus 10. I get the square root of 54.
And to reduce that, I need to do a factor tree of 54 to 27, 9, 3, 3, 3. So square root of 54 is the square root of 2 times 3 times 3 times 3. 2 of those
comes out. It's 3 times the square root of 6. Right, so now we've done h of g of 2 and g of h of 2. So next we're going to do 3 of them nested. So f of g of h of 1. So how do I do that? Well, I can't do g until I know what h is. So h is going to be my first function. Then, once I have h, I can do g on the output. And then finally, I'm going to do f of that output. All right, and when we do that, it looks like this. All right, and every time we get a new input, we can just turn the crank. Right, turn the crank. So we're going to put 1 as our first argument. 4 times 1 minus 3 is 1. So now the output and the input are the same, but that's my input to g. 2 plus 10, this is the square root of 12. And I'm going to call that 2 times the square root of 3, because I can, which makes 2 times the square root of 3 as my input to f, and I have 6 times the square root of 3 minus 7 as the answer to f of g of h of 1. right? Really not all that complicated if you can start thinking about functions this way. So let's reset and do the next one. Okay, the next one, h of f of g of -3. G's on the inside, and then f will come after that, followed by h. Okay, we've got our little assembly line here, and what's my input? My input is -3. So I'm going to stick -3 in here. 2 times -3 is -6. -6 plus 10 is 4, and the square root of that is 2. 2 is my input here. 2 times 3 is 6 minus 7, -1, which means we put -1 in here. 2, 4, -1 squared is 1, so 4 plus 3. The output of h of f of g of -3 is 7. All right. Next one. Now we're starting to see some weird stuff. Now we want f of 1. But you tell me, that's not actually difficult. You showed us how to do that already. We just need more copies of the same machine. Okay, now we start getting to the interesting ones. F of 1. Okay, well, let's set that up. First, I need to do the last one, so f of 1. Okay, and then that output goes into another f, which I happen to have a couple extras here. And that output then goes into another one. And so I've set myself up to do f of 1. So I'm going to put 1 goes in, 3 minus 7, -4 comes out. Then I feed -4 into f again, and I get -12 minus 7, which is -19. And I do it a third time, and I get -57 minus 7 is -64. So f of 1, close, equals -64. Okay, the last three do some interesting things. They don't use numbers as arguments. We're going to use x. And so let's see how we do that. They're going to create a new function called c of x, right? And we'll call that guy down here. This is c of x. And that's equal to f of g of x. All right, so what we're going to do is we're going to make another little machine that is inside of c of x, is f of g of x. Now we do the inside first, so we want to have g of x feeding in to f of x. And we're going to feed in x. So that then becomes, the output is square root of 2x plus 10. Feed that into f of x, and I end up with 3 times the square root of 2x plus 10 minus 7. And that's how you do that composite function. All right, next one, we're going to define d of x as h of f of x. Hopefully this is getting boring for you right now because we're doing the same thing. Let's look inside of d of x, and my f of x is going to be the input to h of x. And I want to use, again, x as my argument and do it algebraically. So x goes in here, 3x minus 7 comes out, and now I have 4 times 3x minus 7 squared minus 3 times 3x minus 7. That's algebra. We're not going to go through that. I think you know how to do it. The key is you need to understand that d of x equals that simplified as far as you can. And then finally, what are we going to do? We're going to make e of x. So let's clean this up, get these out of the way, and we've got e of x equals f of h of x, right? Same thing. H has to go first. So I'm there, and then I put f, and my inputs are x, and then out I get 4x squared minus 3x. That's my input here. Multiply that by 3, and I get 12x squared minus 9x minus 7. And that is e of x is 12x squared minus 9x minus 7. And that is all these problems, and hopefully you have a good idea about how composite functions work. This one's been a lot of fun. So, as usual, give me some comments, give me some likes, subscribe if you like, and if you're interested in tutoring, come look for me at rockpiletutors.com. If you mention you saw this video, then you'll get a discount off of your first session. Have a great evening, everybody.